Alright guys, we're going to kick off algebra review with a little review of expressions and equations. So expressions have no equal sign and equations do have an equal sign. In fact, equations are made up of expressions. So here are some examples of some expressions. It could be as simple as just the letter x, or you could complicate that and do something like x plus a number. We could make it really fancy and do 3x plus 2, all sorts of things. But, we could even add a second variable if we wanted to. Okay, so it doesn't really matter as long as there is no equal sign. You could even put it over and divide by a number. Okay, so that is even an expression. An equation is if you would have like y equals 2 plus 3y. So it's just two different expressions being set equal to each other. So what we're going to be looking at today with expressions is what happens if you add the expressions, and then we'll do it again and see what happens if you subtract two expressions. You have done this in algebra, but this is going to be a quick review. So you can see this is an expression and this is an expression, and we're going to add them together. So the first step in adding is actually to get rid of the parentheses. So get rid of parentheses. Okay, why can you just get rid of the parentheses? Because adding doesn't affect this guy. There's technically a 1 right here, and by distributing that positive 1 in, it does nothing. So we can just get rid of the parentheses and write this down. 3x plus 15 plus 2x squared minus x plus 4. Okay, and then you can just start combining like terms. So I like to work in order of highest to lowest degree. So this would be our highest degree. And unfortunately, it does not have a buddy. So that just goes by itself. You can kind of check it off and say done. Moving down, we would land at the 3x and the negative x. That would combine to positive 2x. Done and done. And then we would have our constants of 15 and 4, which would combine to equal to positive 19. So I always give a final glance over to make sure that there are no more common terms, which there aren't, because this is x squared, this is just x, and this is a constant. So this is as simplified as it's going to get, which makes this my answer. A lot of you are going to want to go ahead and solve this, but remember, there's no equal sign, so you actually can't solve it. This is as far as you can get. This is a simplified expression after adding two expressions. All right, now we're going to go ahead and do a similar thing, except you can see that there is a subtraction sign rather than an addition sign. So if we're subtracting, we actually can't just get rid of the parentheses because we need to distribute this subtraction sign into the parentheses. Remember before, and I can actually show you, before when we did this addition problem, I kind of hinted at we were distributing, it just didn't do anything. Like distribute a plus sign in there, it's not going to change anything. So we just ignored it and got rid of the parentheses. But down here, we're not adding, we're subtracting. And when you distribute a negative sign in, it does do some things. So we need to do that before we just get rid of the parentheses. Now the first set stays the same. So I'm actually going to write us a little reminder that it stays the same. So we're just going to write 5x squared plus 8x plus 12. But the second one, it switches, which maybe you want to just draw a little arrow. Why does it switch? Because we're distributing this minus sign or negative sign or opposite sign in here, which is going to make every sign turn into its opposite. So when I distribute it, the positive, that's a positive, right? The positive 3x squared becomes a negative 3x squared. And the negative 10 becomes a positive 10. Now you might be tempted to pull this down, but we actually already distributed in, so we don't have anything here, which means this really could scoot over. So let's just go ahead and write this so it looks a little nicer. We're just gonna smash everything together and write 5x squared plus 8x plus 12 minus 3x squared plus 10. Okay, now it's what you're used to doing. We're just going to combine the like terms. I always like to start with my highest exponent. So that would be the 5x squared and the negative 3x squared. You know that 5 minus 3 is 2. So we have 2x squared. Check those off because they're done. Then we'll look at our 8x. If we're going down the line, that's the only x term. So we're just going to keep it plus 8x. Check it off. And then plus 12 and plus 10 are our constants. So those combine to plus 22. Since there are no more like terms, that is our final answer. And what you just said is that this is the same as this. It's just simplified. So this is a little more usable if we would ever need it.